In this video, we're going to continue our exploration of circular functions. And this time we're going to use the coordinates of the point on the unit circle to extend the trig ratios beyond the angles found in right-angled triangles. We're going into the other quadrants, quadrants 2, 3 and 4. So let's have a look at angles in this second quadrant over here. So we're going to be referring from this quadrant back to this quadrant. Okay, this is the first quadrant. Okay, so you can see that this image here is clearly symmetric about the y-axis. So we're going to use that fact to help us to discern that the coordinate points for this point here are related to the coordinate points at this point here. Okay, so the x and y coordinates for this point over here are negative a, because it sits over this section here, so minus a, and positive b. So the sine value for both of these angles is the same, and the cos value for both of these angles, this distance here is a distance of a, and this distance here is also a distance of a. And so the value that you get, the actual size of the number that you get, is the same, but the sign is different, whether it's positive or negative. So we can write the relationship between the two angles that we've got here. The angle in the first quadrant, which is theta, and the angle in the second quadrant that we also measure from that positive x-axis side, which is that angle there, that blue angle, which is in fact pi minus theta. So let's look at the relationships that we've discovered. So we have that sine of pi minus theta is the same size as sine of theta, so they're equal to each other. And we have that cos of pi minus theta is the same size as cos of theta, but it's the opposite sign, so it's negative. So let's look at the tan relationship. So for tan of this angle here, we use the point at the circumference and the point in the centre of the circle to create a straight line and extend that line in whichever direction we need to until it cuts this tangent line here. So the x-coordinate of that point is 1 because it's on the line x is equal to 1. And we'll use the fact that the distance that point is below the x-axis is the same distance that our other point that has coordinates 1c, which is that distance is c, is above the x-axis, which means that our coordinate for our point down the bottom is the same size c, but it's negative. So that makes our relationship for tan of angles in the second quadrant the same size as tan of the same angle in the first quadrant, but negative. So let's make a little summary of which of the trig ratios is positive and negative in the second quadrant. Sine of angles in the second quadrant is a positive value. Cos for angles in the second quadrant is a negative value. And tan of angles in the second quadrant is also negative. Now let's look at angles in the third quadrant. So here we are in the third quadrant, so we're round to here. So our angle that we're looking at now in the third quadrant are going to be angles of the form pi plus theta. So let's just go through our trig ratios. Sine of pi plus theta, so pi plus theta round to here, this is our angle. Our sine value here is the same size as sine of our reference angle or our referred angle in the first quadrant, but it's negative. And so we will have that sine of pi plus theta is negative sine of pi. If we look at cos of pi plus theta, So we come around again, we're looking at our cos value, so we're reading off our x-axis. And again, it's the same size as cos, but it's also negative. So this value here is negative. And to read our tan value, we go from the point on the circumference through the point in the middle and continue in whichever direction is going to allow us to intersect the tangent line. And we end up at this point here. So tan of pi plus theta is in fact exactly the same as tan of theta. So in summary, our trig ratios for angles in the third quadrant are: our sine values are negative, our cos values are also negative, and our tan values are positive. Now for the fourth quadrant. So in the fourth quadrant, the angles that we're looking at are measured all the way around from the positive x arm all the way around. So our angles are 2 pi minus theta. So our point is down here on the circumference. So our cos value is A. So that's the same as the cos value in the first quadrant. So they are the same size. For our sine value, we read across to the y-axis and its value is negative b, whereas the one at the top is positive b. And so our value for sine of 2 pi minus theta is in fact the negative value of sine theta. Our cos value we said was the same, so it's the positive version. It's exactly the same. And for our tangent, so from the centre through the circumference, point at the circumference, out to the tangent line, you can see that the value is the same, but that it's negative as well. So we could also do this using the angle that is measured in the opposite direction this way, using the angle minus theta, and that would look like this. We just replace all of these angles here with minus pi, and the rest is exactly the same. The negatives are still sine and tan, and cos is still the same value. So in summary, in the fourth quarter, sine is negative, cos is positive, and tan is negative. So let's summarise that all together. So in every quadrant that we had, sine, cos and tan had the same size, same magnitude as in the first quadrant here. So the letter for cos, which is A, stays the same letter A whether we were in the first quadrant, in the second quadrant, in the third quadrant, or in the fourth quadrant. What's different is whether it's positive or negative. And so what we're going to do is we're going to make a little summary on a unit circle of the trig ratios that are positive in each quadrant. So in this first quadrant, our cos value is a positive value, our sine value is a positive value, and our tan value is a positive value. So all of the trig values in the first quadrant are positive. In the second quadrant, our cos value is negative, our sine value is positive, and our tan value is also negative. So the only trig ratio that's positive in the second quadrant is the sine ratio, S for sine. In the third quadrant, our cos value is negative, our sine value is negative, and our tan value is positive. So in the third quadrant, the only trig ratio that's positive is our tan ratio. And then finally, in the fourth quadrant, our cos value is positive value, our sine value is a negative value, and our tan value is also a negative value. So in this fourth quadrant, the only trig ratio that has a positive value is our cos value. And this little circle here is what most people use to remember which trig ratio is positive in which quadrant. And in fact, they don't use the word all, they'll just use the letter A. There's different mnemonics that you can use to remember this. A couple include the fact that it spells the word cast if you start down in the fourth quadrant. Another one is that it spells the word sacked, like I'm all sacked out. I'm sure you can come up with your own, but you need to remember them. So, in summary, to find the trig ratios for an angle using the unit circle, there's three things that you need to do. Now, the first two dot points you can do in a different order, but both of them need to be done. And one of the things that needs to be done is you need to identify the reference angle or the related angle in the first quadrant. Okay, and as a hint, it'll have the same denominator as the angle that you're working with. And then secondly, you need to identify the sign, positive or negative, for the trig ratio. Not the angle or anything, but whether the trig ratio is positive or negative for that quadrant. And then finally, you need to put the two things together, work out what the trig ratio is, evaluate the trig ratio, what size is it, and then attach the appropriate sign to it. So let's have a go. So if sine of theta is 0.3, find the value of sine of pi plus theta. So we need to work out, first of all, which quadrant that's in, and pi plus theta puts us in the third quadrant. And in the third quadrant, only tan is positive. And so our answer is going to have a negative sign in front of it. And the value that we get will be exactly the same value as sine of our reference angle, which is sine of theta. And we know from up here that sine of theta is 0.3. And so sine of pi plus theta is minus 0.3. For our second question, our angle is 2 pi minus theta. So 2 pi minus theta puts us in the fourth quadrant here. And in the fourth quadrant, only cos is positive. And so our answer for sine of 2 pi minus theta is going to be a negative value, and it's going to be the same size as our reference angle, which is sine of theta. And so we know from the top of the question that sine of theta is 0.3. So our answer is negative 0.3. And then finally, you don't need to keep drawing the pictures. We've got in for our last question, sine of minus theta. And so we know that minus theta is going to be in the fourth quadrant, and using our positives and negatives in the fourth quadrant, the only thing that's positive, is cos. So our answer is going to be a negative value, and is going to be the same size as cos of theta, which is 0.3. Let's have a go at another one. So we've got here that cos of pi on 4 is 1 on root 2, and they want us to find cos of 3 pi on 4. So we can use the denominator of our angle here to tell us what our reference angle will be in that first quadrant. And because our denominator is 4, our reference angle is going to be pi on 4. So we can write it equal to cos of pi on 4. And now we have to figure out whether there's a positive or a negative value that goes in there. So looking at our unit circle, 3 pi on 4 is the same as 3/4 times pi, which is less than a pi, which means that our angle is in here. 3/4 is more than half a pi, which takes us to the 90 degrees. So we're working in the second quadrant, and according to our ASTC, the only thing that's positive in that second quadrant is sine, so our cos value must be negative. And you can also see that if you just look at where, from this point here, it comes down and it sits for cos, it sits on the negative side of the x-axis. And so we know that cos of pi on 4 is 1 on root 2, so our answer for cos of 3 pi on 4 is negative 1 over root 2. Now our second example goes beyond our normal unit circle rotations. And so you can get some weird ones like this. You can even do something like cos of 110 pi on 4. And what you're looking for is what is the closest multiple of 4 that's close to 9. And that multiple of 4 is 8. So I'm going to rewrite this 9 pi on 4 as 8 pi plus pi on 4. And then we can split this into two fractions, which gives us 8 pi on 4 plus pi on 4. The 8 and the 4 will cancel, and we're left with 2 pi plus pi on 4. So that is in the first quadrant. And from our positive values in the different quadrants, that means that our cos value will be positive because all of the trig ratios are positive there. And so cos of 2 pi plus pi on 4 will be the same as cos of pi, because that's our reference angle in that first quadrant. And we're told at the top of the question, up here, that cos of pi on 4 is 1 over root 2.